All right, time for another video. Last we left off with a lot of information on files and getting started with writing code and all the information you may or may not need to write code, practice it, learn it, whatever else. So I think this time we are going to be picking up with date and time. There is a way to get current date and time into your programs so that way when your program runs, if it's not you running or somebody else running it and stuff, it'll actually get the current date and time of whenever that program is run. That way you can use that in your program. So the ctime library allows us to work with dates and times. To use it, you must import the ctime header file, which it gives us an example right here. We can go and get rid of this. In fact, I'm going to go ahead and remove this old file right here, which because it was just an example file. That should have cleared the file also out of my file explorer as well. When you delete files or move files around in here and stuff, it should also delete them out of there. I'm gonna go and get rid of this one too because I feel like that challenge was completed and stuff, even though it wasn't my creativity that did it and stuff. It kind of showed me how to do it in the next video when I did that challenge thing. So I'm gonna get rid of that as well. Simplify that a little bit. Now we're gonna clean up all this code real quick. Get back to the simple stuff here we got. Get rid of this library and add in a new library to start demonstrating or exploring how to include time. And then it's got a comment here in the example. So import the ctime library. Okay. Display current date and time. The ctime library has a variety of functions to measure dates and times. The time function gives us a timestamp representing the current date and time. We can use the ctime function to show the date and time that a timestamp represents. And then we got another example here, display the current date. So to get this done, let's go ahead and put this into our program here. And it looks like we're going to go straight to the main with this. So first off, we got a comment here, get the timestamp for the current date and time. And then the code for that would be time underscore t timestamp. So we're just declaring a type right here, which is time type, and giving it a variable name, and then time looks like, and a reference for timestamp. And that is being declared. And then we got another comment down here, display the date and time represented by the timestamp, and then an output. I am not familiar with this very much. I've seen it before, but haven't dealt with it enough to fully understand it, but I'm going to try to decipher it the best I can. So first we got the library in place and stuff. which includes a bunch of code to be able to pull the current date and time. I don't know where it's getting that information from. Like I said, I'm not very familiar with it yet. But in order to include date and time, you will need to include that library unless you build your own library for it. So we're using time underscore t as a type, which I'm pretty sure that means time type. A timestamp as a variable name, just declaring that, and then time uh, is going to be the reference point of whatever is stored in timestamp. And then we have an output. Um, so I'm guessing this may have a value currently set to it of whatever the current time is. But whatever's in that location at the time you run the program, because you don't want to actually get, if you declare it at one point in the program, it'll have it set. But that time is consistently changing. So instead of once you get to this line of code, and this is just all an assumption on my part, because like I said, I don't know exactly how it works. I'm just seeing it for the seeing it for the second time, but more than getting refreshed on it. I'm guessing time is going to end up having a value of whatever the current time is, what's over in that location. And then we're going to use ctime to output the reference in that location. So let's go ahead and save it and run it and see what we get here. By the way, my time, it is currently 5:10 p.m. Military time, that would be roughly 17:10. So let's see if that's what it prints up. Yes, it prints up that it's Monday, June 15th, which is correct. So it's printing up the day in two different ways. It's Monday, and that's correct. June 15th, and that's correct. And that is the actual correct time and the year. So this right here is the exact date and time of right now for me. So yes, this right here code works. Um, did I doubt that it works? No. But running the code and making sure it works means that my compiler is working fine, the program's working fine, everything is pretty much working the way it's supposed to for this library and this type of code. And it's always a good idea to check. So even if you put that code in there and you learn to do that and stuff, but you don't test it by running it, doesn't mean that it's actually going to work. If it doesn't work, then you have either a problem with your compiler, your program, um, or other things, uh, which is something we're going to cover in the next section after this section here. So now, reading on here, two ways to use the time function. The time function writes a timestamp to the memory location given by the parameters, but it also returns a timestamp's value. An alternative way to use a time function is to pass a. Okay, so I'm guessing this is actually a function right here. This is the declaration that we're going to use this the function. This is a parameter, which means it'll run that whatever time is in that. So, but yeah, an alternative way to run time function is to pass a null pointer and use the return value instead. So instead of writing it out like this, the way we have it, it looks like you can alternatively put equal to time and null. And we haven't discussed null at all. In fact, I'm not even familiar with null yet, but I'm assuming with that right there, we can actually get rid of this right here. And that should be the same thing. Again, don't know for sure till we run it and try it out. And yes, it's still printing them at the exact same time. So you can use it with the function. That way, get the location of timestamp, which is the variable, which already has a value set to it, but since time is ever changing, you would want what's in that location and not what is in that location when it got to this line of code. Because once you run the program, if it takes 5 minutes for the program to run, then your time's going to be elapsed by 5 minutes. So when it gets this right here, it saves a value. If you were just to print up this right here, for example, I change this to, let me get rid of this right here. I declare this right here, just declare it. Change this to just timestamp. And like I said, this is morely just an assumption since they're using the reference point. Save it. Now, I don't know exactly what the second is right now, but I'm pretty sure there's going to be a difference between that. If I just run this like this, actually it's giving me a huge bunch of numbers, which I'm not even sure what that is. So it's a value set. So this value right here actually represents all of what it was, but probably in machine code. No, I don't know. I have no idea. Because there's no 2026 on there. There's nothing. It's just a huge number. So I am not sure. So yeah, if you want to get the time, I suggest you work on getting it memorized where you either write it this way, time, null, and then coming down here and putting ctime, parentheses, reference, like that. Save it, run it. And we got the correct time, or you can put it the other way that they had it here, where you're using the function instead of setting the value, which is time, parentheses, reference, time, stamp, declared. Oops. What am I missing there? Oh, yeah, I put it as a pointer. My bad. It's only one key difference from a 7 to an 8 with the shift on it. So save it, run it. There we go. Okay, data types. There are two different data types used to store the date and time. The timestamp that we're using right now for timestamp, or struct TM for date time structures. So if you want to use this in a structure instead of using it this way right here, is gonna, I guess there's a way of doing that too. Timestamps represent a moment in time as a single number, which is what we must have gotten before as a single number. It was a large number, but it was still a single number, which makes it easy for computers to do calculations. Okay, so that number that we got before and stuff, when I would change this all around, you got that huge long number, must be used probably for the computer. So if it wants to calculate two different points of time and tell you the difference between those two different points of time, it uses that instead of using what it prints out in this situation, which makes sense. If you want to know the difference between when somebody was born, the day, the month, the year, the time, and tell them how old, tell that person how old they are today. So you would use one to subtract the other, I guess. But let's keep reading here. Date time structures are structures. They represent different components of date and time as members. This makes it easier for us to specify dates. Date time structures have the following members. Okay, so we have a bunch of different members right here. TM underscore second, minute, hour, uh, M day, uh, Mon. I'm not sure what that one is. So the second is going to the seconds within a minute, represent the seconds within a minute. So here's let me go ahead and get this all written down just in case you can't see it. So TM underscore second, the seconds within a minute, TM, which not only can you see this, but it's also helped me kind of remember what these things are just by typing them out too. The minutes within an hour, TM underscore hour, the hour within a day, parentheses from 0 to 23. So we're getting kind of a theme here and stuff. So TM underscore M day would be the day of the month. TM underscore mon would be the month from 0, from 0 to 11, starting with January. And then we got TM year, the number of years since 1900. So I don't know if it'll go back farther than that or not, but TM underscore W day, the weekday from 0 to 6, starting with Sunday. So that's good to know. So it starts with Sunday as 0. TM underscore Y day, the day of the year from 0 to 365 with 0 being January 1st. And then we got TM underscore is DST, which is going to be positive when daylight savings time is in effect. Is in, yep, effect 0 when not in effect. And negative when unknown. Okay. So we got the seconds to give you the seconds, the minutes to give you the minutes, the hour to give you the hour. And since we have 24 hours in a day, 0 is going to be the first hour, 23 is going to be the last hour. Then we have the day of the month. And then we have the month itself, starting with 0, ending in 11, 0 being January, 11 being December. And you think about that as an array. Elements in an array, the first one, it starts with 0, not 1. That's where they're getting the zeros from, because it's in an array. So this library includes all that. with several arrays for all this stuff. Year, the number of years since 1900. So I don't know if it'll go back later or earlier than that, but then we got, hold on a second. All right. And it looks like we got weekday here. The weekday starting from 0, which is Sunday, going to 6, which would be Saturday. And we got year day. So since there's 365 days in a year, it'll give you what day it is throughout that 365, 0 being January 1st. Now, of course, if there's a leap year in there, I don't see anything in there for leap year because I know that's an extra day, which is like the 29th of February. So I'm not sure what that would be. But then is daylight savings time. I'm going to say that's what that stands for, is daylight savings time. Positive uh, when, I didn't spell that right, not a problem. Positive when daylight savings time is in effect, 0 when it is not in effect, and negative when it's unknown. I'm not sure how you would go about unknown, but I also do know that not we write code for a lot of things anywhere around the world, and I don't know who all takes into effect daylight savings time. I know some places and stuff people just don't understand it, and that's perfectly fine. Um, some people that use it and stuff don't even understand it fully. But it's just the idea that the code is in there for that. That if you know what it is and know how to use it, you can. It's there. So, like I said, the only thing I don't see there is leap year. So, which is the 29th of February, I believe. I don't know if anybody takes that into effect all the time or not, but there I go with my yawning again. My gosh. All right. Always keep in mind that the way that date components are represented. Hours are represented in 24-hour format. 11 p.m. would be 2300. So, in order to use any of these right here codes, especially the one dealing with a 24-hour day, if you want what the hour is of the day, you need to really understand how, for where I'm from, military time works. Somebody else may consider that being standard time because they're not used to, not that everybody in the world uses the whole AM and PM thing, I don't think, but still. Um, the month go from 0 to 11. For example, December, yep, we've already discussed that years would represent relative to the years. So the year 2024 will be represented as 124 because that's 124 years from 1900. Okay. Creating timestamps. The time function can only create a timestamp for the current date, but we can create a timestamp for any date by using the mktime function. MK, so that's a new one right there. Was there anything else that was new in here besides that? Null. Yeah, so null is new. We don't know what null exactly is. That's what I was. So null is new and currently unknown. Because I don't think we've discussed null yet in any of these lessons. Going back down here, so the MK function converts a date time structure into a timestamp. Here's an example, create a timestamp using MK function. So we've got another example here. Looks like we're going to still need that same library still since we're dealing with this. Are we going to get rid of all this? It looks like we are. Now we got to keep this right here in the bottom. It looks like we're going to keep this right here. We're going to get rid of these comments because we don't need them anymore. This comment too. I'm trying to look and see. Yes, we need that, but I don't think we need this. No, we don't need this. Okay, so we can adjust our code to get the example written down here. So struct, which we've talked about this before, tm, date time. Now, I don't think this looks exactly the same as what our normal structures look like, but this is how you would structure a date and time. From there, put down. I'm going to pretty much type this out multiple different times, but each one's going to be a little bit different. So, date time, dot time underscore year. Um, from there, I'm going to go ahead and copy this and then print it off. Let's see, 2, 4, 6, 6. We're going to do 7 times. So 3, 4, 5, 6, 7. Okay, and then the only thing we need to actually change is the year to mon for the month, then year to day, and then year to hour, and then uh, year to minute, and year to second. And then we're going to have a comment here, daylight savings must be specified -1 uses the computer's time zone setting. And so what it actually means by that, because the time that you have on your computer is actually not coming from your computer. The time you have on your computer is coming from the server that your computer actually, and I don't know much about networking yet, but if I had to guess, most of the time that data is constantly being sent to your computer. Now, it can probably keep time by just once you turn your computer on, ask it once what time it is, and then there's probably a program that runs with your system that just continuously tracks time. But once you turn it on for the first time, it's probably trying to get that. Um, no, that wouldn't be true, because if you're not hooked to the internet, because I can disconnect from the internet and still have the correct time. I know I may not. I don't know. It's probably stored in my computer somewhere, and when I turn it on, it probably keeps running. Because if I know if I turn my computer off, I don't know if the internet actually tracks it or not. You would actually have to check and test that out. Phones, you would have to literally to see if they keep track of time. Phones you wouldn't be able to do because they're going to consistently have some sort of signal no matter what. You cannot turn off the cellular signal at all. You can turn off the Wi-Fi, but not the cellular signal, so it may always continue to track time. When it comes to a laptop or a computer, it may not have the right time in it, or it may be programmed into the software. I don't know. That's not a question I can answer. So I started saying something about that. I'm going to retract it now because I cannot answer that question, honestly, since I do not know how that program actually operates. But anyways, we got our comment in there. So let's just stick with what it's saying here. Daylight savings must be specified -1 uses the computer's time zone setting. So we will scratch what I said and continue with the example here. This one right here is going to be the daylight savings time. Okay, and all these are going to have set to a specific value. This is going to be -1 declared. We're going to go back up here. This one's going to be 1 declared. This one's going to be 30 declared. This one's going to be 12 declared. And yes, keep saying declared because declared is kind of my way of saying I need a semicolon in there to end this statement. 17 value of 12 to 1, and then another value of 2023 to 1900. Then we got a couple comments in here. I'll go ahead and add number of years since 1900. And this one right here, number of months since January. All right. So let's go ahead and save this. I think that's everything. Yeah, I think that's everything. Actually, no, it's not. We need to change this because this is no longer referencing timestamp. It's referencing date time, not timestamp. Actually, no, it is still referencing timestamp. I'm looking at the wrong thing, my bad. So we actually do have one more bit of code here we need to put in, which is timestamp. Set to MK time with a reference of date time. All right. Now we have all the code in there. So I think my computer may be doing some upgrades or something like that because it's running the CPU a little hard. Not too excessive, just more than normal. Okay, so we have our example put in here. So I have I'm looking at this. We got the structure right here. This does not look like your typical structure though. But yes, we got a structure with the type of the structure and then the variable name for it. And then we got our timestamp declared statement right there with the variable. So the current time is actually in this location right here with this variable name. And then all of our date times are being declared with the different date time structures that it was talking about before, all the way down. And then we're going to use our variable timestamp to get the MK time and give it a value. So this is the value of timestamp right here, which is the keyword MK time with what's in that location, this one right here. And then we're going to output our variable here. So let's save this, run this, and see what we get. I'm pretty sure we're going to get a bunch of numbers. I'm just not sure how. But anyways, let's go ahead and print it up and see what happens here. Kind of curious myself because it's been a while since I've done this. So it gives us still the same thing. No, it doesn't. Okay, so the year is showing 2023. I did save this. Yep, 2023 is still showing the year. Not my current year. It's showing the year we have set. So it's showing 2023, which is related to 1900. It is showing December right here. So 2023. So, yep. I am not fully sure where it's getting this data from. So Sunday would be the first day of the week. '17. Yeah. And it does have unknown in there for not sure if it's daylight savings or not. Yeah. So I'm not able to decipher this right here because I'm not fully sure about what this is doing. Um, I guess this is just showing us how to use this, and we're just discovering it is all we're doing right here, because trying to decipher this, I'm not sure what I'm looking at here. Um, 1 second, I see that, 1 second, 30 minutes, 30 minutes, 12 hours, 12 hours, the day of the month, 17th, uh, the month, which is 12 right here. I'm not sure what the minus is about. I think the minus is 12 minus 1, so it's representing 11. And then this one right here would be 1900. Always, it looks like it's always going to be 1900. So if I change this right here to 26, which is what the current year is, it should represent 26. Basically, it's subtracting these two, giving that number that there is currently 126 days, so the computer can see that and then print up that year that it's currently in, because the computer wouldn't understand what this is right here if it sees this specifically. It would have to do the math and use that value uh, to determine what day it is, or what year it is. So that's kind of my assumption on this, because it's not very specific. So maybe my other sources and stuff will help me understand this a little bit better. I think they actually do, but I'm not sure. But yeah. Moving on. Creating timestamps. Nope, nope, that's what we just did. Note the MK time function needs these members to have values MT year, MT month, day, etc., etc., all of them, the ones that we currently have. But that's talking about the MK function, which the MK function is right here. Yeah, I'm still kind of lost on this right here. Anyways, and I probably won't understand it until I get to my other source, so I'm just declaring this as something I'm seeing it. I think I've seen it before, so it's kind of refreshing something in my head. Details will have to come in my other source. So, um, it looks like we have another example here. Creating date time structures. MK function also fills in the MT day and MT year day members of the date time structure with the correct values, which completes the structure and gives a value date time. It can be used for for this example, to find the weekday of a given date. Find the weekday of a specific date. So they recreate everything. It looks like the same stuff. So we got an example here. Um, we're not using this right now because we're not using the current time. We have, let's go ahead and type this in here, I guess. Comment first, create the date time structure and use MK time to fill in the missing members. Okay, and we're gonna clear this right here because it doesn't look like we need that right there. Um, but we have the year, which is the same, the month, which is the same, the date, which is the same. The only thing difference is the hour, which we're going to change to 0. And instead of having the minutes, seconds, and so forth on separate lines, they just have it on one line, which I'm going to keep that all the same. I'm not going to put it on one line. The only thing is I'm going to adjust these values here, 0 and 0. You still got this right here. They don't have the comment in there anymore. And then we're going to change. Sorry. Don't know why I keep yawning. I do it a lot in my videos. Oh well. Oops. There we go. So they have this code in here right here. Standard string It looks like they have an array, weekday, oops, square brackets, and what this array represents, which is, I'm actually going to go down to the next line and print this all out so it doesn't run off the page. So we have Sunday, Monday, and yes, this is kind of something I've never done. Well, I've done it before, but I've done this, made lists like this instead of having it run off the page right there, because even theirs runs off the page. But instead of doing that, I'm just going to put it right here in a list type form. It's the same way though. We got a square brackets and everything is inside the square brackets there. I'm listening to my computer there. Obviously, it's downloading some stuff, I guess. So Tuesday, Wednesday, and Thursday, Friday. I'm just getting all these days put in here. I'm being distracted by something else right now. I apologize for that. Saturday. I'm trying to finish this up at the same time. Okay, so we got all that written in there. It doesn't look like our output's going to be the same anymore, so we're going to change the output here a little bit. Oh, don't forget, declare it. Yep. So our output's going to change a little bit here too. We're going to have some, there we go. The date is on a space, and then, not the end of the line, week, days, and then the array. Date, time, dot, tm, underscore, w, day. All right. So we got the example written in here. Again, because I don't fully understand all this right here, it's going to be kind of hard. I know that this is an array. The array is a string. The variable name for the array is weekdays, which we're using down here. Since we got this example written in here, we got some content right here, which is going to be represented by the array. We're going to use date time. So this is the array. We're using date time and W. I may have not to put that in there right. Let's see. No, W day. Weekday. Okay. Weekday, yeah. And we want to know what the weekday is probably based on this information up here. But let's see. I think we're just going to output the weekday. Date, time, W, day. Or do I not? Is that part of it? No, I don't see the W day in there. I am missing something though. I got 6, 7, 8. 6, 7. I'm missing one. Year, month, day, hour. So 3 of those, yes. Hour, minute, seconds. There is, no, there's only 5, 6, 7, 7 there. Okay, and we got 7 there altogether. The only thing I'm missing is this right here part. The MK time referencing date time and declaring that. Yeah, as you can see, this right here is something I'm going to have to practice, read through, go through a few times to understand it, but at the same time, I have not yet gone through um, the libraries to fully understand them. Which, in order to understand this right here, you're going to have to understand the ctime library because it has a lot of information. Most libraries do, though. So let's go ahead and save this and run it. And the date is on a Thursday. So using this data, I'm guessing it is trying to determine uh, something. Yeah. I, I honestly, I don't think I'm learning much of anything right here. I think I'm just discovering some stuff and not really learning anything because it's not giving enough information for me to fully understand this. I know my other sources do, but this right here just is not. It's like, here's this right here, figure it out. And that's what I kind of see. Let's see if it has any more information down below here. I know this is getting to run into 45 minutes to an hour already. It looks like this is going to be a long section because there's lot of information to cover. But anytime you deal with a new library, there always is. It could take you a full week to fully understand a new library. And since we're dealing with a new library right here, which has, in my opinion, this has nothing to do with classes. And in my opinion, also files has nothing to do with classes. But that's just me. Templates, maybe yes, but not this. This should have been something covered up here in the tutorial, not in classes section. But so the local time and GM time functions can convert timestamps into date time structures. The local time function returns a pointer to a structure representing the time in the computer's time zone. The GM time function returns a pointer to a structure representing the time in the GMT time zone. This function returns a pointer to a date time structure. If we want to make sure its value does not change unexpectedly, we should make a copy of it, dereferencing the pointer. To learn more about dereferencing, yes, we've already gone through that. We haven't learned everything about them, but we've learned everything about them that this source has to offer. And then we got an example here to get a date time structure. Uh, and this keeps going. It looks like there's a lot here to cover for this right here. So I think I'm going to go ahead and cut the video off right here. Uh, once I get this example written in here and we see what this does, because I'm going to be kind of clueless on this because it's not very specific on its information. I mean, GM function returns a pointer to a structure representing the time in the GMT time zone. I'm not sure what GMT time zone is, but I don't know all the time zones myself. But it's apparently going to give us a GMT time zone or a local time zone using a pointer. So we'll go ahead and put this right here, this last bit of example into it. Then I'm going to cut this off. Next time I pick up, we'll come back to display dates and we'll go through that because there's quite a bit more still to learn about this. But in my opinion, it's giving us a very brief understanding of a library is what it's doing. Um, Here's the thing about this, and I'm going to mention this now. I probably won't even write this example in here. So, in fact, I'm going to bring this up over here and add something else in here. This right here. Okay. So I'm jumping from this right here to this right here. This is literally going through a little bit of data on the time library. I guarantee it's not going through all of it, even with what I have left down here to go through. I'm just kind of summing this up right here, right now. Um, time library, where is it at? Diagnostic library string, text, memory management, meta programming, general utilities. Look at all these. These are the standard libraries. These are the libraries that were built um, back when C++ was probably new. There may be some of it that's new. Like meta programming didn't come out until 11, as you can see right there. There's the date and time library. There's the input and output library. The IO streams is the input and output library. The date and time library is the one we're currently using now. Um, I don't think that this is part of basics though. The basics is pretty much everything over here on the left side. Okay. Once you get into starting to study library, like language support, concepts, and there's a lot of them. There is, I think, 14 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, more than 14, 15, 16, 17 libraries. These are the standard libraries. The information that we want to cover is just the basics, basically from language down to named requirements, maybe a little bit in headers. I'm not even sure we want to cover that. So everything we've been covering so far has just been in language right here. Templates, classes, uh, C routing, functions, declarations, statements, expressions, basic concepts, the ASC2 chart, and processor components. Yeah, preprocessor. And it's jumping into a date and time library. It hasn't even done this one yet. I would think that this would be more part of the basics than date and time would be. Yes, you may need to know the date and time, but you're also going to need to know the general utilities, the input and output, all these other ones. And that's not even getting into the technical specifications of standard libraries. I mean, there's still a lot more to go through. So I am probably not going to finish up with this section right here just because it deals with a library. And libraries are not basic. They are not. They are not part of the basic C++. C++. They are the standard, but not part of the basics. I do suggest learning the libraries because they are very helpful, very useful. But I would learn the basics first. The IO streams, in fact, once you learn the basics and the keywords and everything, because like syntax, output, comments, those things are basics. We're going to get into errors and structures next, and then namespacing next. Um, then projects and keep going on and stuff. I don't know if we'll get to all this or not. This one right here, it literally covers a lot of these libraries. IO streams, F streams, CMath strings. There is 1, 2, 3, 4, 5, 6, 7, 8. It covers again ctime. There's 8 here, and I just showed you there's actually a total of 17 libraries. So yes, libraries are, in my opinion, are not part of the basics. And we need to learn the basics first. So I may not cover the rest of this because this is covering a library and it doesn't even cover all of it. Maybe when this was first came out and stuff, it may not have been updated for a while, but yeah. Just a quick summary. So we got an example right here. I'm not even sure what the example is doing, even looking at it. Then we got display dates. Then we got another example of correct date before displaying it, representing the current date in different ways. A bunch of symbols that go with dates, measuring time. And I think that's a little off topic for basics, in my opinion. I don't mind coming back to this point right here when I've studied libraries from a different source. Um, but especially since they don't even have all the libraries in here. But yeah, I would rather move on to errors at this point in time. Come back to this at a different time or use another source to learn it. Because this is just, in my opinion, very confusing. I mean, I can go through this, but I'm not going to understand all of it. I'm going to be discovering it. But either way, I am going to cut the video off at this point in time. It looks like this one right here is going to basically begin, get a date time structure and output the current hour. But I would like a better understanding of these keywords first. And yeah, it doesn't, this one displays the GMT, this one displays local. We got some of these right here, but the values, I don't understand them completely. Coming back up here to the values, the number of years since 1900. So why do we have a value of 2300 minus 1900? Is that so the computer can read it and determine what the actual year is? You put in the current year minus 1900, which shows the computer or the program or the compiler how many years it is since 1900 so that it can display the correct year in the output. I don't know. Anyways, if you have any comments for this, if you like the video, click the like button. Comments, put them in the comments. Questions, comments. Like I said, libraries is not something I think we should be into yet. We haven't. My other source kind of does the same thing, but going through this, discovering it is part of it. And yes, discovering this library, yes, and finishing up through the library, we may go ahead and pick up right here just so we can finish this up. But I can tell you right now, all I'm going to be doing at this point in time is discovering it, and I'll probably go through it real quick as fast as I can. But I won't be able to decipher the code since I don't know all the keywords very well yet. Like there's another one right here, ASD time. So from here, we've been using ctime function to display the date yeah, anyways. I'm going to shut it off right there and probably pick it back up right here at this point in time. Like normal and stuff, if there's anything that I've said that's wrong, you're welcome to correct me in the comments. But until next time, this is where we're going to leave off. We'll pick it up here. Next time, finish this up and then get into errors. So until next time.